Hi everyone. Today we are going to be, and the next lesson is going to be about writing variable expressions. So the last unit was on numerical expressions, and now we're going to add variables to it. So I want you to remember that I'm expecting you to take notes. Please don't just watch the video, take notes so you're engaged in your learning. So right now I would like you to pause the video and do these 3 questions to see if you remember how to use bar diagrams to show addition. Alright, let's see if we match. I did my bar diagram. I have 3 right here, and then I added 5 more, and I showed that it was the 3 and the 5 by putting it above. And then how would it look if you were asked to show 5 plus 3? So now I have my 5, and I have my 3. I have my 5 here and 3. And are they equivalent? Remember, equivalent means the same. They add to the same quantity. They mean the same thing. So yes, they are equivalent because they both add to 8. So let's start using variables. Remember, a variable is just a letter that represents some quantity. So it says draw a bar diagram to show a plus 2. So I don't know how much I don't know what it means. I know it's a number, so I'm just going to make my a that big. And then plus 1, 2. So that's 2. And this is a. Can you please pause and show that 2 plus a is the same quantity as a plus 2? Alright, so here is how I drew. I have my 2 in the front this time, and then the a. And they're the same amount. They're the same quantity, so they are equivalent. So given this whole idea of a plus 2 equals 2 plus a, see if you can write the sum of m and k in 2 different ways. Well, one way would be having the m first, m plus k, and then the second way would be having the k first, at k plus m. The property that allows us, we've been learning about different properties, and we're going to be talking about the distributive property in a few days, but the property that lets us change the order of the numbers in addition problems, so changing the order of the numbers in an addition problem, is called the commutative property. And I'm not going to fit it in this blank. Commutative property. It lets us change the order, it lets us change its place. So this is how I think of it. If you commute for your job, that means you go to a different location. So here, the location of m was first, and then we'd use the commutative property, and so it changed locations. It went to the second. So the commutative property allows us to change the order of the numbers in an addition problem. And we're going to be using that to simplify expressions in the upcoming days. So let's try subtraction. Draw a bar diagram to model 10 minus 6. Alright, so here's the model that I drew. I started with 10 squares, and then I highlighted 6 of them to show that I was taking them away. So this is my bar diagram. So what expression does this represent? Well, if we show 10 minus 6, so what expression would this model? Oops. 10 minus 6. Jeez. Could we also use 6 minus 10? Could we change the order? So think about that. Does 10 minus 6 written like this mean the same thing as 6 minus 10? No, it doesn't, because 6 minus 10 does not equal the same quantity. This equals 4, where this, and some of you know how to add and subtract positive, negative numbers already, this actually equals negative 4. So does the commutative property work with subtraction? No. The only way it does, and you will learn more about subtraction, changing it to addition coming up, but if we wrote 6, and we change that subtraction to adding the opposite, then once it's addition, then the commutative property would work. But we can't just switch orders if it's subtraction. All right, how can we write an expression to show 3 less than a number? So first I want you to draw a diagram to model this subtraction. So are we taking away from the 3 or the unknown? Well, we have some number and it's 3 less than that. So I'm going to have some number, and I'll just say, since we've been using A, I'll say this is A, and we're taking away 3, like this. So what would that represent? It would represent, A minus 3, not 3 minus A. The A was not being taken away from the 3. So the reason I point this one out is because that less than messes people up sometimes, because they want to put the 3 before because it's in the beginning of that phrase, but with less than, it actually comes after. So how do we write an expression showing C is being subtracted from the sum of A and B? So again, this lesson is about writing an addition and subtraction problems, writing expressions. So C is being subtracted from. So C is being taken away from some number, but we're going to start with that expression for the sum of A and B, because C is being subtracted from the sum of A and B. So this is A and B. And now we're going to subtract C from that. But if you think about order of operations, what this is telling us is that C is being taken away from the sum. So C is being taken away from the sum. Now in this case we wouldn't have to have the parentheses because order of operations would go left to right, but many times the parentheses matter. So let's look at another one. Okay, so C minus the sum of A and B. So instead of C being taken away from the sum, now we're subtracting the sum from C. So we're subtracting. So why are the parentheses necessary for this one? Well, this one, it's necessary because, think about it, if we did not have parentheses here and we just subtracted from left to right, we would only be taking away this A, not the B. So the parentheses are necessary. I'm going to say that again. I suggest you write it down. The parentheses are necessary here because we're subtracting the whole sum, not just A. If we did not have parentheses, we'd be subtracting the A and adding the B. Now we're subtracting the whole thing. So I want you to pause and I want you to do this part before continuing. See if we come up with the same things. Replace the variables with numbers to see if these two are the same. So for the ease, let's just all use the same numbers. Let's use A is 1, B is 2, C is 3. So plug those in and see if we come up with the same thing. Okay, so first I want to talk about the word evaluate. It does not say evaluate here, but in the future when you see that word evaluate, it means just this. We replaced, anytime there was an A, I put a 1 in its place. When there was a B, I put a 2, and when there was a C, I put a 3. And I rewrote all of my symbols right in there. And then I used order of operations. So here I had to do the parentheses first and then the subtraction. Here, because there were no parentheses, I had to go left from right. So I subtracted the 1 and then added the 2. So you can see these do not mean the same thing. Here we are just subtracting the A. Here we're subtracting the A and the B. So when you're writing, and yes, you will have to do this on your assignment and assessment, make sure that you read carefully to know if you need to put the parentheses in. All right, so this is the end of the lesson, just some practice before you begin your assignment. I'm going to do some with you and then have you do some after the video is off. And again, I know this is trusting you to really do that, but then you can check to see if you're doing it right. So an easy one, write two expressions to show W is increased by 4. So remember, we could write it W plus 4, or the commutative property lets us change the order with addition. All right, let's go down here to one of the more difficult ones. Write an expression to show 4 less than the sum of G and 5. So we have that G and 5, and it's 4 less than that, like this. Now, because it's all addition subtraction from left to right, and you're taking 4 away from the sum, we don't need the parentheses. But I will be honest, anytime I see that word sum or difference, and it's this, I'm taking something or adding something to it or multiplying, I put parentheses just in case. Okay, so it was 4 less than the sum, so I'm putting parentheses there. All right, please pause and do the rest and then come back and check to see if we have the right answers. All right, let's talk through these. So this one I had to write 3 different expressions. I actually wrote more than 3 as long as the order is different. So the commutative property tells us that if you're adding numbers, the order in which you add them does not matter. So I could do A plus B plus C, B plus C plus A, B plus A plus C, C plus B plus A. So I think there's 6 of them that you could have written as long as the order is different. Next one, write an expression. Oh, by the way, notice how I highlighted and underlined. Remember to annotate, pick out the important parts. I want to see how you're underlining, highlighting to pick out those important parts. So to model showing 3 less than P. So here I know that I am taking whatever P, whatever quantity P is, whether it's 10 or 20 or 30 or 867, I am going to be taking 3 less than that. So it is P minus 3, 3 less than P, not 3 minus P, like this, because we're taking 3 away from the P. Here, the difference of 3 and P, so now whatever comes first is the first thing in your expression. And all right, and then again this last one, it's 4 decreased by, so we know it's going to be 4 minus the sum. So it is extremely important that you have the parentheses in there because you're decreasing 4 by the sum of G and 5. So the parentheses need to be there. All right, how'd you do? All right, so you can start your assignment. It's very, very short, and then there's also an iExcel. We out.